Okay, so we went on and we found 2 times 6 is 12, and 5 times 8 is 40. These do have a difference of 28. If you needed a positive 28, you would put positive 40 and negative 12. If you needed negative, you would put the negative in front of the 40. Let's go back up and see what we had here. We need a positive 28. So we need the 40 to be a positive. So let's go back down, or let's just erase some of this and put it right here underneath it. Okay. Now we're going to have, let's see, what was it we had here? We had 2, 5, and 6, 8. So let's put our 6 and 8 on there. And we need to decide where our 2 and 5 go. We had a 12 and a 40. Okay? The 40 was 5 times 8. So we need the 5 to be over here. Here's our 40. And our 2 here, that'll give us our 12. So we have 12 and 40. We need a positive 28. So our 40 needs to be positive, and our 12 needs to be negative. Okay? Yeah, this is the long ones that took a while to learn. But this is our answer right here. Okay, this one won't be as hard. This is a special thing that we've done. Number 9 is 4x squared. 4x squared minus 9. When there's 2 of them, you need to look for common factor or see if it's the special product of like difference of squares. Are these both perfect squares? The x is a square. 4 is squared, right? It's 2 times 2. 9 is 3 times 3. So what do we do with the difference of squares? What gives you 4x squared? What times itself? 2x. We put that at the beginning. The 9 is what? 3 times itself, right? And then you put a plus and minus. You can't write that with the little squared on tops because they're not the same. They have, one has a plus, one has a minus. Number 10. X squared minus x minus 12. Okay. There's nothing they all have in common. It's not a difference of squares, it's just a straight factor. X squared is x times x. 12 could be 1 times 12, 2 times 6, 3 times 4. You need it to subtract to give you a 1. There's not a 1 there, but you need to, you actually want a negative 1 because there's a minus here. So subtract to give you a negative 1. Which ones subtract to give you a 1?
3 and 4.
3 and 4. How are we going to get a negative 1? Negative 4, positive 3, right? So we're going to have the positive 3 here and the negative 4. And as long as you get those two factors, it doesn't matter which one's first. You could have x minus 4x plus 3. Okay, we're going to get a new page here. Okay. Number 11, we got another difficult one here, a little more difficult. One of those we have to do a lot of figuring on. 6m cubed plus 9m squared plus 3m. What do we need to factor first? Do they have anything in common? M and a 3. So we'll put 3m out front. To get 6, 3 times 2, right? Do we need some m's? M squared, right? Plus 3. M or no? Yes? Plus 1. Oh, the 1's not going to be hard. It's only 1 times 1, right? Okay, so let's see if we can factor this. We know it would be 1 times 1, and the first ones would be a 2 and a 1. We just, I guess it doesn't matter where, does it? Because they're both going to be multiplied times a 1. So let's put it here and see if it does work. 2m and 1m, or just m, right? You don't have to have the 1 in front. This is 1. This is 2. It has to add to give you 3. Does it do that? Is 3 positive or negative? Positive, so they both need to be positive. So put your pluses there. And we do have an answer, a final answer there. Neither one of these factors can be factored any farther. You need to check, look at this. Does it have anything in common? Or is it a difference of squares? No. Look at both of them, make sure you can't go any farther. Okay, that one wasn't as hard as the other one, huh?
12.
Okay, number 12, 3w squared minus 75. Is that a difference of squares? Is 75 a perfect square?
Yeah.
No. Is 3 a perfect square? No. Is there anything they have in common?
They're both to be divided by 3.
They have a 3 in common. So let's factor the 3 out. So we have w squared minus what?
25.
3/4 is 75, right? Now is it a difference of squares? 25 is a perfect square. So we leave the 3 out here. And we have w in the front. 25 is what times itself?
5.
So we put the 5's. And what do we do for a sign? Minus? Plus and minus, right? Now, neither one of these are a difference of squares. That's as far as we can go, right? They don't have anything in common. So we have a final answer there. And that was number 12. Okay, number 13. 60x plus 45x squared plus 20. What do we need to do first? Descending order. So we'll put our x squared term first, 45x squared, then our x term, it's a positive, plus 60x, and then our last term, plus 20. Do they have anything in common? They don't have an x in common. How about a number?
5.
5. That's as big as it goes, right? 10 goes into 2 but not the other. So we'll factor 5 out. Our first term, 5 times what is 45? 9. X squared. Plus 5 times what is 60?
12.
12. And we need the x. Plus 5 times 4. Okay, we need to see if we can get this factored. The 4, this is another long. The 4 is either 1 times 4 or 2 times 2. At least it won't be as long as the 48 was. Okay. The 9 can be either 1 times 9 or 3 times 3, right? The 1 times 9 we can do both ways. Okay, so